Hello! This video is an intermediate level look at special cases of filename substitution in the Linux shell. Specifically, I will focus on wildcard matching hidden files and handling of file names starting with a dash. This is not a beginner tutorial, and I assume that you are already familiar with the general concept of bash filename expansion. If not, I strongly suggest that you watch my beginner tutorial video first, linked in the video description. Consider the contents of my example2 directory, which has a mix of non-hidden and hidden file names. The -a option of the ls command shows all files, including the default dot and dot system entries. In this specific case, the dot refers to the example2 directory, while dot represents the parent to example2 called backup, which I happen to be in right now. These two special entries are shown in each directory listing on a Linux file system, where they are used to logically interconnect directories into a hierarchical tree-like structure. The dot and dot entries can be classified as hidden, as their names start with a dot. However, they are a separate category from user-created hidden files and directories, and I will explain in a moment how this distinction matters. First, let's have a look at the following command line, which will use a wildcard expression to perform a common task of copying files. This command copied a number of files from the example2 directory into tmp. I used the -v verbose option so you can see which files were processed by the command, but you can always use the ls command to check the command results. This command copied 4 files, all matched by the asterisk wildcard inside example2 directory. It is a common misnomer where the asterisk wildcard, used on its own the way I just did, is described as matching all file names. To be precise, the asterisk wildcard alone matches only non-hidden file names. The dot, if present at the beginning of a file name, is special, and normally it is not matched by wildcards under bash, the default Linux shell. This is why a couple of hidden files I have in my example2 directory were not copied here. Regardless of which wildcard is used, the question mark, the square bracket character class, or the asterisk, none of them will normally match the dot at the beginning of a hidden file or directory name. Matching hidden files using wildcard expressions is possible, however, it is not handled consistently across different shells. I am using bash, the standard Linux shell, so what I am about to discuss applies to that shell only in the current version 5. Under bash, with default settings, it is possible to wildcard match hidden file names if we start the glob with a literal dot. Consider the following command. In this case, I use the square bracket character class followed by an asterisk to match user-created hidden file names in the example2 directory. This command's wildcard expression matched 6 files, which happen to be all user-created hidden files in example2 directory. One could be tempted to use a generic dot asterisk expression, but this shell will include the system dot and dot entries with it. Let's try it anyway and see what will happen. What happened here exactly? The files I wanted to copy were copied, but the dot and dot entries were also matched by the wildcard. Because dot and dot entries were matched, the command tried to copy parent and current directories in their entirety, which is not what I intended. Fortunately, this time nothing bad happened since I did not include the -r recursive option with my cp command. Unintended results of such poorly structured command could be difficult to reverse. Certainly, the rm command with such wildcard could cause irreversible data loss, but even a cp command may overwrite files without prompting by default. Using the dot asterisk expression is a common, naive attempt to capture all hidden file names. In most cases, we actually want almost all hidden file names, excluding the dot and dot entries. It would be very unusual to want to match the dot and dot entries using a wildcard. In fact, you should do everything possible to exclude these entries from being matched through wildcards, otherwise you will get undesired results, as you have just seen. As a matter of principle, I strongly advise against using the dot asterisk wildcard expression in bash. Instead, you need to craft a unique wildcard expression every time in order to match hidden file names. This is relatively simple in some cases, as I did earlier using a square bracket character class, but it may be difficult or even impossible depending on what names your hidden files have or how many there may be. In order to match almost all file names, excluding the dot and dot dot entries, you may need to provide two wildcard expressions with a command, one for non-hidden names and one for hidden ones. Here is a full command which will copy almost all files from my example2 directory into TMP. If you are familiar with the use of curly braces, you can also shorten the command by employing them here like that. Neither command is an elegant solution, but it works, and both versions are fairly easy to understand. Advanced users employ the dotglob shell option, which allows using a single wildcard expression to match both non-hidden and hidden file names. Perhaps more importantly, the dot and dot dot default entries will no longer be matched, simplifying the process of wildcard matching. As demonstrated previously, it was necessary to use two wildcard expressions customized to specific contents of a directory in order to copy almost all files from example2 directory. With dotglob option in place, the equivalent command will only use the asterisk wildcard, resulting in a simpler command. You can match non-hidden or hidden file names separately with dotglob in place, but the globs will be now different than when dotglob option was not active. For example, if I want to match all non-hidden file names now, I need to exclude the leading dot using a character class. This expression matched file names inside example2 which do not start with a dot. Conversely, to match only hidden file names with dotglob enabled, the dot needs to be explicitly enclosed in square brackets. Here I copied all hidden file names from example2 into TMP. If you want to enable dotglob permanently, you can add it to the bashrc shell configuration file. I prefer to enable it only when needed. Of course, you are not limited to the asterisk wildcard with dotglob enabled. You can use the question mark or the square brackets as needed to build more specific and complex ambiguous path names. Shell file name expansion can get complicated very quickly. This is why I recommend to use a glob with the echo command to test it first, and only then move on to the actual command that makes changes to the file system. For example, now I would like to remove hidden files with names longer than one character. I will test it first using echo. Seeing echo output and comparing it with the actual list of files inside example2, I can now run the remove command with confidence. The .c file was not removed as its name is only one character long. The hidden file name dot is just one of the possible cases which may require special handling whenever we use wildcards on the Linux command line. But even without hidden files, the file names themselves can break a command line. Consider the following situation. I have the following files in my present working directory. Let's say I want to copy these files into the TMP directory using a wildcard expression. The command for that is very simple. In this case, the asterisk matched all 8 non-hidden file names in my present working directory. The command worked fine and produced an intended outcome. The potential problem here is that starting an ambiguous name with a wildcard or using wildcards on their own, like I just did, is actually tricky territory. Sometimes matched file names may result in incorrect command behavior or an outright data loss if unusual file names get matched. Particularly file names that start with a dash cause problems. For example, I will create an extra file called -c here and run the above cp command again. This time the cp command failed as the "-c file was understood as a command option and not a file name. The fact that the cp command does not have a "-c option is not that important. What matters is that a command may not work or may work incorrectly if a glob matches a file with a name that starts with a dash. The troublesome nature of dash-leading file names is not limited to only commands with wildcard expressions. Let me show you such scenario. I will try to remove the "-c file now. You will notice that the rm command error provides me with a hint how to overcome this problem. I can add a /prefix before the file name with a leading dash. Now the rm command worked as expected, and the "-c file has been removed. Adding a /prefix solved the problem, and this prefix is the recommended workaround for file names with leading dashes. As another example, now I would like to create two files with dash leading names. You know already that this will not work. I need to add the /prefix to each of these unusual file names. There is an alternate method to handle file names with dash leading file names, which relies on adding a double dash to the command line. I used that method earlier to create the original "-c file. A double dash tells the command that anything to the right of that double dash is not to be interpreted as a command option. I will use that method to remove the "-c file now. Either method is fine, but the "prefix is preferred, as some command lines may have wildcards in the middle, or the command used may not support the double dash. Let me show you one more example of how file names with leading dashes can cause trouble. Let's say I would like to interactively clean up my current directory using the rm command and the * wildcard, forgetting to use the /prefix. Normally, the rm command with -i option would prompt me for each file name whether I want to remove it. Let's see what happens in this specific situation. Ironically, with the exception of the -f file, everything inside my present directory is gone. In this command, the -f file name was interpreted as an option by the rm command, where it means to force the remove. The -f option overrides interactive options such as -i for rm command, and this is why I was not prompted. You need to eliminate the possibility of matching the leading dash in file names when using shell wildcards. While you may employ good file naming rules and never use such file names, they may exist on your file system anyway, created by other, less knowledgeable users or by poorly written programs. Fortunately, dash-leading file names only cause problems in relative path names and only when referred to directly or wildcard matched in present working directory. For example, the /prefix is not used in the following command. Here, the wildcard is at the end of a relative to home path name, so there's no danger of file names being interpreted as command options. Let's do one more example. This command uses a relative path name, but the glob does not start with a wildcard, so /prefix is not used. Expressions such as C** cannot match a file with a leading dash in the name. The next video in this series discusses wildcard matching regular files versus directories. But before you continue there, make sure to give this video a thumbs up and subscribe if you are not a subscriber already. Thanks for watching.